Hello everyone! In this short video, we'll give you an overview of our full course on machine safety. In the complete course, we walk through the core principles of ISO 12100 and related standards, and show how they support safe design, safe operation, and effective risk reduction for machinery. Let's begin! The full course is structured into 3 parts. Part 1 provides a brief introduction, selected terminology, key concepts, and selected definitions. This section also introduces the approach to risk assessment and risk reduction. Part 2 takes a deeper look at the risk assessment process. Part 3 focuses on risk reduction measures. Throughout the course, we include practical examples to support understanding. In this summary video, we'll highlight the core ideas of machine safety, namely risk assessment and risk reduction. We begin with risk assessment. Risk assessment follows a systematic process to analyze and evaluate machine risks. Risk analysis includes defining the limits of the machinery, identifying hazards and hazardous situations, and estimating the risk level for each hazard. Risk evaluation then determines the overall risk and whether additional safety measures are needed. This structured approach ensures a thorough and consistent assessment of machine risks. In the full course, we explain each step in more detail. After assessing risks, the next step is to apply protective measures to eliminate hazards or reduce risks. These measures involve both designers and users, but design stage measures are prioritized because they are generally more effective than anything added later. ISO 12100 describes this hierarchy of measures in the 3-step method. Step 1. Inherently safe design measures. Step 2. Safeguarding and complementary protective measures. Step 3. Information for use. Step 1 is the most important, and Step 2 takes priority over Step 3. The overall goal is to reduce risks as far as practicable, ensure safe operation throughout the machine's life cycle, and maintain a good balance between safety, usability, and cost. Now, we'll look at a few examples from each step. Here are some examples of inherently safe design measures. First, geometrical aspects. This includes improving visibility from a crane cabin to reduce blind spots, or removing sharp edges and unnecessary openings in food processing equipment. Second, physical aspects. For example, collaborative robots designed with force limits to prevent injury, or conveyors designed with reduced mass and speed to limit kinetic energy. Here are some examples of safeguarding measures. First, fixed guards. For example, a conveyor drive covered with a bolted mesh guard to prevent access to moving parts. Second, interlocking guards, such as a lathe with a safety door that stops the chuck when opened. And third, self-closing guards. For example, a circular saw with a blade cover that automatically returns to its safe position after cutting. And finally, some examples of information for use. On machine labels, for instance, warning symbols placed near rotating spindles. Instruction handbooks, providing clear and complete operating guidance. Packaging, with safety symbols and handling instructions. Together, these 3-step measures support safe use throughout the machine's entire life cycle, from installation to operation and maintenance. To close this video, we'd like to briefly introduce who we are and how we support our clients. At Trondheim Consulting, TROCO, we thank you for joining us for this short introduction to our course on machine safety. Safety is not an add-on. It is something we design in from the very first step. For any inquiries, feel free to contact us by email or phone. Visit our website at troco.no for more details, and stay connected with us on LinkedIn and YouTube for updates. We support safe and compliant machinery, from concept to operation. Thank you for watching this short introduction. We look forward to welcoming you to our full course on machine safety.